So today we'll be covering chapter 3 of class 10th science, metals and non-metals. Physical properties. Metals. The easiest way to start grouping substances is by comparing their physical properties. Their physical properties are properties that are available outside or that are physically available, or you can see physically, like the materialistic properties, like something like this pen, this rubber grip, it is soft. This pen, the plastic is hard, and if you take this paper, this is smooth. So these are the physical properties which are available from the which can be seen from the outside, which can be seen, which can be felt from the outside. Those are physical properties. The easiest way to start grouping substances, the easiest way to start grouping different kind of substances is through by observing their physical properties. Let us study this with the help of the following activities. For example, activities 3.1 to 3.6, collect the sample of the following metals. These are some metals. So let's start with activity 3.1. Take samples of iron, copper, aluminium and magnesium. Note the appearance of each sample. Clean the surface of each sample by rubbing them with sandpaper and note their appearance again. So before their appearance, their appearance before rubbing it with sandpaper and after rubbing it with sandpaper, you should notice it. So metal in their pure state, in their pure basic and raw state, in pure form state, right? They have a shining surface, and this is a property. This property has been named as metallic luster. It has been named as metallic. That is metals luster, metals shining. Activity 3.2. Take small pieces of iron, copper, aluminium and magnesium. These are all metals. Try to cut these metals with a sharp knife, and note they have written small pieces, pieces that you can cut with a knife, right? You don't need to take a piece this thick and this big, just a very small piece of a metal, of these metal. So you can cut them with a knife, and then hold a piece of sodium metal with a pair of tongs. Always handle sodium metal with care because it is highly reactive. Dry it by pressing between the folds of a filter paper. So filter paper will soak all the water and moisture from it. Put it on a watch glass. Watch glass is nothing but just put it on a plate, simple plate, and try to cut it with the knife. What do you observe? You will find that metals are generally hard. The hardness varies from metal to metal. So we will find that most metals that we took were mostly hard. They were of a hard substance. They were made of a hard substance and were difficult to cut. So we can conclude that metals are generally hard, but their hardness also vary from metal to metal. Like iron would be much harder than zinc. Then lead could be harder than zinc, or copper could be harder than lead, and zinc could be less harder than copper. It would be something like this. So their hardness varies from metal to metal. So take pieces of iron, zinc, lead and copper. Place any one metal on a block of iron and strike it 4 or 5 times with a hammer. What do you observe? So you took a piece of hair. Let's do this activity. Here suppose you have this rectangular piece of metal, then you put it on an anvil. Here you put it on an anvil, suppose, right? And then you strike it hard. Please pardon my drawing, I know it's really weird. So you just strike it with a hammer. You strike it with hammer on a piece of metal. Strike it with hammer 3 or 4 times. What do you observe? There would be some kind of depreciation in the metal. The metal would kind of depreciate a bit. It would change its shape. It would go inside itself, and it will decrease in size a little bit, right? These are observations. This is the observation that you will make. So what does this indicate? You will find that some metals can be beaten into thin sheets, and if you take an even smaller piece of metal, say you take this much piece of metal and strike it hard with a hammer 3 to 4 times, then you will notice that this has become a flat sheet, a kind of flat sheet like this, right? So metals can be beaten into thin sheets. This property of metal to be converted or to be changed or to be beaten into thin sheets is called malleability, right? So, and I'll tell you an easy way to remember all these properties. Okay, I'll tell you a very easy way about how you can remember their different properties. So suppose this is malleability, right? Malleability. So how are you going to remember malleability? It is very easy to remember. Malleability, uh, you can take it as melting, right? Malleability is equal to melting. You can just keep it in your mind that malleability is nothing but melting. So this was an iron before, an iron bar or anything, and then this melted like this to form a thin sheet, right? To form a thin sheet. So it went from there to this level. It went from this level to this level, right? It went from this level to this level. So what happens, like suppose it's a block of ice, then ice will metal and spread like water, like this. So metal will also be like a block of ice in the starting, it's in its shape, and then after it has been beaten into a thin sheet, it will go on like the melted form of an ice, like the melted form of the ice. It will look like the melted form of an ice, right? It will spread out, it will thin and spread out, just like an ice block will after it has been melted down, right? So you can take malleability as melting, malleability and melting, and this is how you can remember it. So moving on, did you know that gold and silver are the most malleable metals? So gold and silver can be beaten into the thinnest of sheets. These, okay, moving on. The ability of metals to be drawn into thin wires is called ductility. So you just need to remember the two names, malleability and ductility. Malleability is concerned with melting, and ductility with thin wires. So only these two properties are of metals being changed into thin sheets and into thin wires. And malleability and malleability and melting will look like a thin sheet, a spread out thin sheet. So you can easily remember through melting that melting is concerned with malleability of metals. So the ability of metals to be converted into thin sheets is called malleability, and the ability of metals to be converted into thin wires is called ductility. You will be surprised to know that gold is the most ductile metal. Okay, gold and silver are the most malleable metals, and gold is the most ductile metal too. So you will be surprised to know that a wire of about 2 kilometers of length can be drawn from just 1 gram of gold. It is because of their malleability and ductility that metals can be given different shapes according to our needs, right? I think this much is already obvious. Can you name some metals that are used for making cooking vessels? Of course you can, like silver and steel. So do you know why these metals are, and copper was also used for making vessels, cooking vessels? Because they have a high, I won't tell you in the start, we'll just read it through. Take an aluminium or copper wire, clamp this wire on a stand as shown in like this. This is your copper wire, and then this is your clamp. I clamp it between these two, and then what do? Fix a pin on the free end of the wire using wax. So this here you've attached a pin using wax. Okay, now heat the wire with a spirit lamp, candle or burner near the place where it is clamped. So you have to start heating it from somewhere around here, from the very beginning of the wire. Then what will you observe? We will observe that this wax will eventually melt. After some time the wax will melt and the pin will drop to the floor, right? The above activity shows that metal are good conductors of heat and have high melting points. The best conductor of heat are silver and copper, of which our cooking utensils are made. Lead and mercury are comparatively very poor. Actually, they are very poor conductors of heat, not just poor. So, do metals also conduct electricity? We'll find out. So, what happens is that you start heating up the metal wire from here. Then this starts absorbing heat and starts spreading it out equally throughout the wire, right? So, the heat is being spread throughout the wire in equal amount. So it goes through it reaches this side and it starts reaching this side of the wire, and when it reaches this side of the wire, the high temperature, because heat is being absorbed by the wire, so the wire has changed its temperature, and the higher temperature of the wire causes this wax to melt and the pin to drop to the floor. Okay, so this was an activity to show how metals actually conduct heat. Now we'll see if metals can conduct electricity too, which we all are aware that they can do, obviously. So we'll see how it happens. Set up an electric circuit as shown in, so this is the very simple electric circuit. This is here is a switch, this here is a battery, and this is a bulb. In these two clips, so between these two clips we'll insert our sample, so we will know whether electricity passes through that sample or not. And obviously it will pass if it is a metal, because even the wires are made up of a metal. Place the metal to be tested in the circuit between terminals A and B. This is terminal A, this is terminal B. So between them we have to put our metal. Does the bulb glow? What does this indicate? The bulb obviously glows. So you must have seen that the wires that carry current in your homes have a coating of polyvinyl chloride. So they have a coating of PVC, that is polyvinyl chloride, or a rubber like material. And why is that? That is to insulate those wires, the outside of the wires, so that when we touch them we don't conduct electricity ourselves, right? What happens when metals strike a hard surface, and what happens as of now we are discussing the physical properties of metals. Okay, so conduction of electricity and heat also come in the physical properties of metals. So what happens when metals are struck hard? So in the previous activity, like here, when you struck a metal with a hammer, it was converted into a thin sheet, right? Because of its property of malleability. But what also happened that it produced a very loud sound. It produced a very sonorous. It produced a very sonorous effect, like it produced a very loud sound. So the metals, do they produce a sound? Yeah, of course they do. Almost everything produces a sound. The metals that produce a sound on striking a hard surface are said to be sonorous, right? So it's not like you took a metal and you dipped it in water, and if it didn't make a sound you will say, why, this is not a metal, it doesn't make sound. So a metal that produces a sound on striking is striking, like hitting it with a huge force, or hitting it hard against something. So on striking a hard surface are said to be sonorous. So suppose this is a metal and this is a hard surface, and you strike it like this, so this is producing a sound. That's why this is a metal again. Now we'll talk about non-metals in the next video.